Welcome to the Startup Grind.
All right, thanks, Rich. Well, hey, everybody. My name is Simi. I work at a company called Swirlds Labs, which is a sister company that the previous company I used to work for was Hedera. And in this transition, Swirlds Labs continues to maintain a contract with Hedera to continue to build their products and services with the teams that we have. And I've kind of done everything. I've done everything from like technical documentation to developer advocacy to writing code to managing products. And so with that, this presentation will cover an overview of maybe the entire ecosystem of Web3. So I'm not going to go into super detail into one specific area, but really kind of give you the overview and then allow you guys to ask questions as I go through. A fun fact, I actually grew up in Folsom. I went to Folsom High and stayed around here and then went to Sac State and went to college there. So Folsom's very home to me. So it's nice to be back in a kind of different light to present on this topic.
Excellent.
Yep.
Well,
Where is this located now?
Swirlds Labs?
Yeah.
Oh, it's actually still based out of Dallas.
Oh.
Yeah, so the company is based out of Dallas and the company's been remote this entire
You have
time since I've joined.
So you don't have to travel to Texas?
We've done like engineering offsites, like maybe like once a quarter we kind of started, but other than that, no.
So most of the people though are remote?
Yeah, the majority of the companies remote, majority of the engineers are in Dallas, but they're not required to come into the office at this time.
Was it remote before the pandemic or is that?
So I was remote since I started with them. The engineering team, I think in the beginning was required to be in office, but after the pandemic, everyone was kind of remote, yeah. Okay, so I kind of want to start with some terms so that in the title we have the word Web3 and Distributed Ledger Technology. Just wanted to kind of go through like what that means. And I really actually, when the term Web3 came around, I didn't even use Web 1 or Web 2 when Web 1 or Web 2 around reference it that way. So I had to do a bit of research of my own of like, well, what does the community define those as? Because I just started learning at the time that Web3 was coined and I started in this industry. So WebX, Web 1, 2, 3 is basically just a term to describe like the evolution of the internet, where it started, where it's been, and maybe where it's going. And who knows, in the future, there might be a Web 4 with like some other evolution of like what the internet means to people.
there cannot be a Web 4 because they are at Web 5 now.
They're on Web 5. There you go. So Web 1 was just the idea of having like pages linking to each other. That's the way that I think about it. I could have a web page, it might have an image on there, it might have colors on there, and it has descriptions on there, but you're not actually like clicking buttons or providing my website data about you when you're kind of browsing through my website, or I'm not offering a service as an application for you to log in and then I'm tracking all your data that's tied to your name and your email and all this kind of stuff. So Web 1 was just kind of like, I think of it as like a maybe database of just information. You can click on things, read things, and consume it, but there is the applications that are actually storing stuff about you. And Web 2 is where...
No cookies in one, or were there cookies in one?
Were there oh, that's a great question.
I think that it would bog down the details too much to debate this because there's actually more than one school of thought on like what the major transition points were. So
Sure.
Cookies existed from the beginning. Web forms existed from the beginning. So, but Web 2.0, I think that from a user standpoint, the key thing to understand is that web pages started to feel like applications.
Yeah.
That I think is like instead of bogging yourself down in like technological differences, it's more like web pages went from informational to I'm interacting with an application.
Yeah.
So we're still in 2.
Essentially, yes.
Right now, well, into evolving to maybe 3.
But I mean, we're trying to bring the Web3 vision into the general population.
We're at the very beginning end of like that adoption curve. So.
But the entrenchment of things like Facebook and other like very centralized applications is counter to what Web3 is all about, from my understanding, is that in a Web3 world, everybody's profile, like in a Facebook type of scenario, would be more maintained by them directly. And
Yeah.
they would have control over all of that data.
Yep.
And the application that they access it through would see their data as theirs, and as opposed to like the way Facebook works, it's like
It takes it and
all that data belongs to Facebook
Yes.
essentially. Like,
And
anything
you can't
just giving it to them.
go in and query Google's database to see what data they have of you. I think you can now request your data and things like that, and there's different organizations that have different policies around it. But when you think about like a database, I think about Web2 just being like a private database that organizations own, and it's owned by them, even though you as users are providing that database information about you that they're using in many different ways. But it's not as
The
easy for
query
you.
thing is the most important thing, because as just a general user, imagine you're like, dude, I saw this post on Facebook. Go to their search function, try to find it. Their search function is not very good.
Yeah.
But you can't extract that data in any sort of
Yep.
systematic way and then search it yourself.
And then take that database and then build your own application to use Facebook's data and then consume it into an application that you're building. You can't do that either.
Right.
So Web3 is kind of the point of view of where you have like a public database that stores all the transactions that were processed within the network, applications, users, anybody can go and have access to that data, consume it in their applications, and see exactly what they've done. So for example, like if I create an account and I transfer money to you, you can go to this thing called a Network Explorer and see that transaction without having to get permissions or access or anything like this. This is public shared database, and an application, whether I built it or someone else does, can call that data into their application without having any kind of blocks to doing that or guards around that. And that data is anonymous, so you don't have, when I create an account on a network and I transact, I'm not sharing my name, my email, or anything like that. The thing that tells me that thing is my account is the ownership of the private key on the account. And that is the only thing that's tied to me, although there's nothing else on there that you can see in that Network Explorer that say, this is Simi's account and she's now sent, you know, five coins to this other person or something like that. So anyways, that's kind of like just a general overview.
By the way, I like that definition because a lot of the Web3 definitions I see are very esoteric. So I actually really like this definition you have.
Oh, great. Yeah. I was trying to make it relatable.
Just have two
Sure.
areas that I really would like some clarification on. So when we talk about the metaverse or augmented reality, is that a two?
It could be either.
Yeah, because you can use like tokens and NFTs and things that you use Web3 technology for in the metaverse. But I think a metaverse is a combination of multiple different technologies.
You understand real estate and law.
Well,
So
sure.
I think the analogy there might help. Is that in a Web2 world, most property is owned by one central thing, and there are people that can have access to it. Like if you go to a mall, you don't own the property you're walking around on, you're just a customer. That's what you're doing when you're using Facebook most of the time. But if you buy a property and you live in it, then you have a lot more property rights, even than if you're an apartment renter. And Web 3.0 is trying to organize the internet in such a way that individual users are more like property owners than they are like just tenants or even just customers who just happen to, you know, be there as long as the company allows them to. You know, that we reserve the right to refuse service to anyone on a mom and pop shop. I mean, that seems fair enough, but when Facebook is in control of the vast majority of people's social interactions online, if they decide they don't like a user because of what they said one time,
All right,
then all of a sudden, then it's just a different.
okay, Tim, let's,
And then one more
thank you.
I'm sorry.
No.
I just thought that might help him like understand.
Tim, just give me a second. Blockchain. Did blockchain come in when you were starting to talk about 3?
We'll talk about that.
Okay.
Yeah, we're going to talk about that in further
I
slides.
just want to put those words up because I wanted to have clarification.
Yeah, sure. We will. We will have a slide on, oh, and it's actually this one. So the other term that we had in the title of this presentation was distributed ledger technology. So I just wanted to kind of provide a definition on that too and what that means. So distributed ledgers, from what I understand, probably before I even got into this world, have already existed. It's not really something new. And what it is, it's basically a network of nodes, so just a bunch of computers that are networked together, they talk to each other, and they all store the same instance of the database on each of those nodes. So if you're an application and you're wanting to read data from it, you can ping any one of the nodes, grab data from it. If your application is submitting transactions to this network, those nodes will receive that transaction, they'll go through this consensus process and then write it to the database. And so in the Web3 world, these nodes are not actually owned by a single organization. And the analogy that I kind of think of here is like AWS or any sort of cloud provider. All of those nodes are owned by that organization and their data center. And that is how they offer that service to their customers. In the Web3 world, each one of us can actually host a node and create a network. And therefore, we are the infrastructure. And we're not owned by a single organization or entity. And we can create it that way. So there are many types of distributed ledgers. And here are the examples. One is blockchain. So blockchain is a type of distributed ledger. Bitcoin and Ethereum are blockchain-based public ledger. And they use blockchain as their data structure to group transactions and get them processed and then added to the database. Directed acyclic graph is another type of distributed ledger. This is just a different data structure and a different way that they organize transactions, get them processed through the network, and then added to the database.
I've never heard of it. Is that you?
No, actually, there's a few protocols out there that use that data structure. Hedera is one of them. So we actually use that data structure to organize like our transactions. We call them events. So we have these events that contain transactions, and then it creates this like directed acyclic graph. And that's how we process our transactions on our network. And so the history of the records stored in this database are immutable. So everything that's been processed is immutable. And I just wanted to call out the difference because sometimes there's this confusing conversation between having an immutable history versus having mutable entities that are stored in your database. And the difference is like if I have an account, there might be something in the history of transactions that says I had a balance of 100 HBAR or 100 coin or $100. However, I can transfer more money into that account and the next entry will say that account now has $200 in it. So you can change the properties of like an entity that's stored in the database. They can be mutable or you can set them to be immutable. But then the immutability part for the Web3 public ledger is the history of it. So you can't modify the entries once it's already gone through consensus and been written to the database, if that makes sense. And then there's this concept of node operators. So node operators is basically like what I was mentioning when I said all of us could install the software on our computer and create a network, and we would be a node operator. You're offering like the infrastructure. You might get paid on fees to operate in this network from the transactions that are processed. There might be other incentives. You might market your own node and say, hey, application developers, send all your transactions to my node. I'm more stable, I'm more reliable, you know, and all these kinds of things. And so just wanted to define like what a node operator is also in this distributed ledger kind of system. Okay, I'm ready for the next slide. So here's kind of an image. Don't mind my poor skills here in creating these diagrams, but this is really just to illustrate. This is like a 5-node distributed network, and this green thing that's in the middle of all of them is the database that each one of them stores, and the database is really like the ledger and history of all the transactions that this network has processed. We can go to the next slide.
Oops.
Okay, so types of distributed ledgers, there are permissioned networks. So a permission network is basically when an anonymous node can't join the network. The data is still public, the database is still public. It's just joining the network to participate in the consensus of transactions that get processed by the network. This example of this is Hedera. So Hedera has a governing body of council members. There's these enterprise companies. Each of them actually hosts a node on our Hedera main network. And nobody can just join that network freely and openly. You have to be invited in to join this network. And then Hedera has a separate roadmap for decentralization to get to a point where any one of us can join this network and participate in this. So there's permission network, so we can go to the next slide.
When would you join there? What's on it? What's the benefit?
So joining as a node, you join as a node operator, and like in the transaction fees that we charge per API call, a portion of that goes to the node operator. So if you wanted to host your infrastructure, host your storage basically for this network, and then also participate in consensus and do all of that work as a node, then your incentive might be that, well, you're going to get paid on transaction fees for all the transactions that you process and the consensus that you participate in.
So, yeah, not to take too far off.
Sure.
But are there some contracts, I guess, and then there's some negotiation about fees? There's
No,
probably
it's-
liability also?
So there's no,
Because my system might be crap.
so the transaction fees are kind of programmatically split into like what the node operator gets. So it's like I think it's like a percentage. It depends on different protocols, how they set it up. But we'll talk about that also more in a little bit more slides. But transaction fees, at least in our network, are split between Hedera, the node operator, and then I think there's like the service fee for calling the API. And so that node operator fee is kind of fixed between each of the transactions that the developer would call. And then that would go into the node operator's account.
I'm still thinking insurance and failure, you know.
Oh, yeah.
You might get to it.
Okay. And then the other type is permissionless. And so this is basically like Bitcoin and Ethereum networks. If you're a node operator and you want to join the network, you can join it, you can leave it. You don't need an invitation or have any kind of restrictions in joining that network. Okay, so we talked about the infrastructure part, which we have like the nodes, we have the database. So now like how do you interact with that network and how do you read and write data to the database, and that's maintained by all the nodes in the network. So transactions, when generally talked about between any protocols, are things that modify the state or modify the database. So it's something that's changing, adding a new row or entry into the database because of something that was changed, an entity that was changed or managed. And for queries, and I think these are probably just standard definitions for queries, but you're basically only reading data, so you're not modifying the state. You're reading something from history or, you know, the latest state of like your account, that its balance, or you know, what the memo field is on that or something like that, some field that's stored in state for your account. And so some examples of like what a transaction is, because we talk about transactions, at least when I heard transactions being like, well, what does that even mean? Transactions, examples of that is like transferring. So I can write a transaction to the network that says, I'm going to transfer funds from my account to your account. That's a transaction. That's something that would be recorded in the database. I can create a transaction to create an account on the network that I want to manage and assign my own private keys to it. I can create a non-fungible token. These are all types of examples of transactions that you can submit to the network that will be recorded in this database that all these nodes share together. Okay, the next one. So then we have the network, we have transactions and queries, how you can kind of read and write to it. These transactions have transaction fees associated with it, and that is how the network or the node operators kind of make their money. So the transaction fees, and it depends for different public ledgers out there. Some of them can be fixed fees to USD pricing. That's how Hedera does it. Others, like Ethereum, like it can go up and down depending on market demand. And other protocols have the concept of miners and things like that that can kind of impact the price of like what you might have to pay for a transaction fee in other protocols. So for us in Hedera, we have fixed pricing. We say create an account is 0.0001 of a cent. And it's always going to be 0.001 of a cent, no matter if H-bar's value is a penny or $10. We charge the same fee irrespective of the price of the coin going up or down. And for all the different protocols would require you developers to pay the transaction fees in their native currency. So you don't pay transaction fees in dollars. You pay it in the native cryptocurrency that the network has. So in Hedera, these transaction fees to write data to the network, or to the database, you would have to pay it in H-bar. And Ethereum, you're required to pay in Ether. And these are cryptocurrencies, H-bar and Ethereum, or Ether. And you would have to go to a cryptocurrency exchange to buy them and own them, and then use them to pay for these APIs, for these API calls.
So Hedera transaction fee is set to 0.00, how much of a cent?
It varies. So each of we have like, I don't know, about 20 or 30 different transactions you can do. Each transaction has its own transaction fee associated with it. And for some of them, they are 0.0001. Some of them are $1, some of them are 10 cents, some of them are 5 cents. Create an account is 5 cents. So,
I mean, 5 cents in H bar, not in dollars.
5 cents in dollars, because on our network, the transaction fees are pegged to the dollar. And then you just have to have 5 cents worth of HBAR in order to pay the network.
So the actual fee, because it's paid in H-bar, varies from one transaction to the next with the exchange rate between H-bar and dollar.
The fee does not, so the amount of HBAR, yeah, would change, because depending on the value, you would only need to take 0.0, let's say like a penny. If HBAR is worth a penny today, then you only need 1 HBAR. If HBAR is worth $10 tomorrow, you only need a penny of that 1 HBAR, fraction of it, to pay for the transaction fee.
Do you have smart contracts on it?
We do have smart contracts, yes.
Do you pay for each line of code like you do in Ethereum? So based on the length of the process of the smart contract, the gas fees can actually be higher because of the complexity of it. So do you have the same thing?
Yeah, so we have we have the EVM, we have the base implementation of it. And are you referring to like opcodes and gas charging and all that kind of stuff?
Yeah, so so if I'm interacting with a smart contract, right, because of the complexity of the smart contract, you're actually paying way for
Storage.
each line of code.
Yeah.
For each line of code that's executed through
Yeah.
the smart contract. So that would add up, so if I'm just like sending ETH or sending something to a wallet, it's a small transaction. But if I'm interacting with a contract, because it's executing those codes, each line, you're basically paying gas for each line of code.
Yeah.
And so.
Contract and code?
Smart contract. What? A smart contract is basically a program that's been written on the blockchain, an immutable contract. And so let's say I'm taking out a debt position. I'm depositing liquidity, one other token, and then taking out a debt position against it. Well, that involves multiple transactions. And so there'll be a smart contract that will actually put that whole process together that you're interacting with. But because of that, you're basically executing multiple lines of code. And so there's a fee associated with the execution of that code.
So that's why you need Simi's network or company or something, because they're gonna execute it for you?
I don't know. I don't know. I'm asking on the gas fee portion is if you're also charging for a line of code.
Okay.
Yeah.
Can I explain?
Sure.
All this is very specific to Ethereum. Okay. So in Bitcoin, transactions are issued by users. Okay. But in Ethereum, they can also be issued. The user can issue a piece of code as a transaction, and then that piece of code can act and issue transactions. So that piece of code is a contract.
Mhm.
Is that right?
Yeah, 100%. So my curiosity is if you guys are doing something similar to smart contracts, are you paying for each line of code also? So you half cent.
No. So we use it, so we have the Ethereum virtual machine that we support.
Okay.
And then it has a set of opcodes that have a set of gas fees, and it's the London hard fork or whatever that is supporting as far as like the gas fee schedule. And then let's say if you were going to create an account or create a token using our network, you could use the ERC 720, 721 standards, or we have a native like token service that you can execute on Hedera without smart contracts. But that same service, we've also created pre-compiled that you can call into your smart contract.
So you have a separate EVM compatible system?
Yes.
That is it using Ethereum to
Yes,
process that?
yes,
Okay.
yes,
Okay, interesting.
yes,
Okay.
yes.
So it's not on Hedera though, processing the transaction?
Yeah, it's the EVM, yeah.
It's EVM.
So yeah, we have our native network, we have the EVM, and then we have services on our native network that you can call in your smart contract because we've created pre-compiled for them that you can write in your Solidity smart contract.
Okay, interesting.
Yeah. Okay.
So is it fair to say that Hedera is built on top of Ethereum?
No.
No.
Okay.
So different chains, you can take the EVM and support it in different chains. That is like sort of Ethereum even though it's called the Ethereum virtual machine, it's kind of Ethereum agnostic.
Making it all interoperable.
Yeah.
So maybe, or I guess, my question is like, what are the people that are paying to have stuff happen in this paying for it? Because it's not just a store of value from what you were saying earlier. It's being used as a currency to make things happen. They're paying for something ultimately. What are some use cases for why people would be having something happen on it?
Oh, on the network? That's actually one of my last slides, so there's a couple use cases that I go over.
And I think that's the, like, I know it seems maybe inside out because you're like, well, I have to explain how it works, but.
Yeah, I kind of was building from like the network layer
And that's
all
the
the way
technology
up.
side,
And
I'm with you on that. You gotta define those terms first, right?
Yeah.
But maybe to make it more understandable, because he's like saying contract, he's like, I know what a legal contract is, it's that. It's like, no, not really.
Yeah.
So I don't know if it would help to like.
Start
connect it in that end.
Is your EVM being paid in Hedera Hashgraph or is it being paid in E?
It's being paid in HBAR. So
Yeah.
we call it WABAR
Okay.
or something analogous to, what
Okay.
it's used to.
But, so you're essentially paying Ethereum cost, but in HBAR?
Not Ethereum cost.
You're not, okay, good.
Yeah,
So
we're
you're-
not Ethereum, so Ethereum transaction fees can be crazy and like.
Yeah, correct.
We don't
So
have,
it's more, the EVM is more like a secondary chain then?
yeah,
That is, probably not even interacting with Ethereum, is it?
no,
No, okay.
no, it's just, it's theirs, yeah.
Okay.
So you won't see any of our transactions on the Ethereum, Etherscan, the Network Explorer for Ethereum. You'd only see our smart contract transactions only on our Network Explorer. It's not
Yeah.
something that.
Okay, so it's, okay, so it's the EVM that's on your guys, basically tied to your guys' chain.
Yeah.
Cool. Sounds very cool. All right.
So you guys kind of got in the weeds.
I'm sorry.
But I guess my main question is what you were just talking about fundamentally why Hedera exists versus Ethereum? Like there's a reason that it.
There are many different blockchains, and they try to achieve different things, they try to do the same thing. It's like, there's many ways to cook something in the kitchen, right?
Alright.
And there's different ways that you can do it, but you still come out with a dish. So each one is kind of doing things just a little bit different. Some things are better than others. Like if you were to go do something on Ethereum right now, depending on the time of day, you could pay anywhere from $10 a transaction interacting with a contract to $50. And it's ridiculous. So,
Okay, so Hedera is trying to create a system where the transaction fees are predictable.
Yes.
yeah,
That's like
The-
key
yeah.
differentiating
yeah,
factor.
that's
That's what-
really important because right now what's happening on Ethereum is you have what are all these things called second layers that people are moving to because it's cheaper to do transactions on there. And then
That's the same thing with like Lightning on top of
yeah,
Bitcoin. right?
exactly,
It's like,
exactly.
You can't
Exactly.
work on the base protocol because it's too slow.
Exactly. So it's like, let's have a protocol that actually can do all this in one. And so that's nice to see solutions like that. And so I think
And then
that's what they're
For
trying to do.
Hedera,
But Hedera is a separate system. It's
It
not-
is. Yeah, it's a different
not-
blockchain.
It's not merely put on top of
Yeah,
Ethereum.
no,
like-
it's
like
not.
Lightning
It's a
only
separate
built on top
blockchain.
of Bitcoin.
It's like Bitcoin is different than Ethereum. Ethereum Hashgraph is
Just
different than
borrowed a
Ethereum.
bunch of Ethereum concepts in
Yes.
its implementation.
Yeah, there's various differences between them all, but it's a blockchain, the concept of blockchain. And I think that Hedera also does a different style of how it handles a blockchain.
Yeah,
versus
yeah.
Ethereum.
Did I catch correctly what you guys were talking about earlier is that Solidity, as it works in Ethereum, works similarly in Hedera, so then at least you have
Yeah, so
transfer of
AVM,
skills from people that know how to write Solidity contracts, they can write them in Hedera.
they're not writing the Solidity, the EVM and the Solidity,
Yes.
are they? Okay, so yeah, so
if you like pour your contract over from Ethereum and deploy it on our
So
system.
you want to leverage that, just like
Yes.
any other, like leveraging of existing programming skills.
Yes.
If
Yeah.
it's the same language, then bam, that helps
exactly,
you
yeah,
out.
and it's called the EVM, which is Ethereum virtual machine, and it's basically like a virtual computer that runs on blockchain, utilizing smart contracts. And so when she's saying that they're doing another component that's an EVM, that's basically what they've integrated in with their Hashgraph in order to do the contract processing.
Yep.
That makes sense? That work?
Yep,
Okay.
that did. Great, we'll move to the next slide. And so then I wanted to just talk about cryptocurrency, and everybody probably knows this, but just wanted to define it because it's something that comes up in this ecosystem. So it's just a virtual currency. It can also be referred to as tokens. So some public ledgers have a fixed supply of cryptocurrency, which means they can't create any more. So in that case, like Hedera is an example, we have 50 billion HBARs, we can't mint anymore, it's a fixed supply, and that's what we have. Others, and I don't have an example off the top of my head, at least not right now, don't have a fixed supply. So they can, Ethereum, okay, there you go, I should know that. So, and you can mint more of those tokens and have it set up that way.
Ethereum has a limit to how quickly they can be created.
It does have, they have a burn mechanism too. It
Whereas
has
like Dogecoin, it's more inflationary.
Yeah, Doge is inflationary, yeah.
By design, in fact, it was a joke originally.
It's a diminishing inflation over time.
I don't know what language you guys have been talking.
All right, I'm happy to ask you questions after.
You don't want to know about Doge anyways, I'm just kidding.
It's just, yeah. comparison.
All I know is there was some guy that was busted in Palo Alto. There's lots of people busted in lots of places.
And then just the ways that cryptocurrencies are viewed. So depending on like what persona you're taking, you're going to view cryptocurrencies differently. If you are a retail user, someone who is just like would want to invest into stocks or something like that, you're going to look at coins as a form of investment. You're going to try to buy low, you're going to try to sell high, you're going to make profits, you're going to day trade, you're going to do all that kind of stuff. And that's great. That's, I think, one way of viewing what cryptocurrencies are. But another way to view what a cryptocurrency is, which is maybe from the point of view of a developer, someone building applications, is you need to buy that coin in order to process and deploy transactions on our network, and then call the data into your application to put in some sort of UI and create an application out of it. So that's like a different way of looking at it, because that person is not, I mean, they might be a retail user too, and they might be buying, for investment purposes. But in that second case, you're actually buying it because you have to pay for fees in that coin. And that's how you have to interact with the network that you're trying to build on top of. And yeah, I think that's all I wanted to say.
This might be a silly analogy, but it's like if you go to an amusement park and they have like an arcade or like the skee ball or all that stuff, it's like you usually have to buy some sort of token that they use as the transaction currency within that system.
Dave and Buster.
Or exactly.
Exactly.
You have to buy tickets, and you got to trade with tickets to get stuff.
And so you can trade in and out of that currency, although most amusement parks is more like once you buy into it, you can't get.
Well, no, they get the teddy bear at the end.
Are you going to explain what non-fungible tokens are? That's something that I really don't know, don't understand.
Oh, yeah. I don't know if I had anything specific in this presentation on that, but I'm happy to chat about it maybe towards the end if we have more time.
Okay.
Or even afterwards.
Or the guy, I feel time.
Yeah.
And just take it offline. Yeah.
Sure.
Assuming there's actually something signed.
Yeah, there is, with your private key. So when you're processing,
Digitally, not.
yeah, digitally.
Digital signature, big DocuSign.
I know, but
So we talked about transactions, we talked about transaction fees. There's another component to transactions when you submit them to a network. They usually need to be signed. Anything that's like modifying something of the entity that you're managing or working with needs to be signed by the appropriate key. So like if I have an account and I want to transfer funds out of my account, I need to sign that transaction with my key to authorize that transfer to go out. If I want to be the owner of or manage a non-fungible token or class of non-fungible tokens, if I want to mint more NFTs, non-fungible tokens is what that acronym stands for, I need to sign with the right key to be able to mint more of those. So whenever you process these transactions on the network, usually there is a signing component of whoever owns the entity that they're managing. And if the correct key does not sign the transaction, the network's going to reject it and say, this is not a valid transaction. It doesn't meet the requirements. Therefore, if no one else in this room has access to my key, there's nothing that you guys can do to change anything about my account. However, if you do get access to my key and my recovery phrase, then you do have access to do everything with my account. So those things are very important to keep private. And we'll talk about that too in a little bit. So keys. So we talked about transaction signing, and I mentioned that you have to sign with keys. And then what are keys? So different public ledgers support different kinds of keys that you can sign with. I think Ethereum primarily supports the ECDSA SEC P251K. Hedera actually supports both. And that's kind of an example of what like a public and private key look like. So when you have a key or when you need to sign, you take that private key and that has to be applied to the transaction that you're signing and submitting to the network. And the private key is usually what users store in their wallets, and we'll talk about wallets too. And that private key usually also has a recovery phrase associated with it. So in the event you did lose access to your private key, you have this 12 to 24 word recovery phrase that you can regenerate that key from. However, you need to store that recovery phrase in a safe place too, because anyone that has access to that recovery phrase can also regenerate your key and do stuff with the things that you own. The public key is, so if I have an account in one of the protocols, and if you're trying to figure out who the owner is, your private key is never stored on the distributed ledger, but your public key will be with like your account. So if you have your account details and you have the key field, you'll see this public key, and then that's how you can kind of tell who owns this account or what private key would correspond to this public key, because you can derive that public key from the private key that someone owns and kind of validate that who the owner is of that account. And we can move to the next slide. So recovery phrases, I already kind of talked about this. So they're usually 12 to 24 words, and this is something that you would need to keep very safe and private. If you lose access to your keys and you lose access to your recovery phrases, there's no way to gain access to your private key again.
Order.
So then you just lose, nope.
Not even close.
If you lose access to it, you lose access to your accounts and all assets that are stored within it, everything is just gone. Like there's no way to bring it back.
NSA.
Nope.
Not even close either.
So in theory, you could crack a thing that's protected with a key, but the keys are so long, the amount of time it would take to
You just
pick
need a
that
quantum
lock,
computer.
it's impractical to do it, even on a governmental level.
Oh, you don't know what it is.
There may be in the future a way of recovering when we have quantum computers. So that's the whole idea.
There's also something our CTO is working on called decentralized recovery, a way to somehow do something with your.
That's not like Ledger's thing that they just did.
I think I saw that. That's like sharing your password like through companies or something like that. Yeah.
Encrypted.
Yeah. I saw that.
Are not liking that right now.
Yeah. And these recovery phrases, private keys are unique. So no one else can generate the same recovery phrase or private key once you've generated yours.
How does the algorithm make sure that that is truly unique?
It's a great question for maybe.
So the public key, I guess a public-private key is a pair mathematically. So basically there can't be any duplicate public keys. That's how you tell.
Okay.
You can't register the private key anywhere, otherwise it'd be giving away what it is.
Yeah.
So it must be that the public key is checked against an existing database of
Keys.
stuff, and it just won't allow a second copy of the same public key.
Yeah.
If you just randomly happen to generate the same private key as somebody else already using, your public key would be the same as theirs.
Yep.
And
I'll follow up with our team to see.
They're
how
kind of astronomical though,
Yeah.
to do that.
the odds are really low, but I've never actually heard of, like if you generate a certificate for like an SSL certificate or even some other one that's not related to that infrastructure, like PGP, like you just
Yeah.
generate a private key. It's just assumed to be unique.
It's soon,
But
yeah.
technically speaking, so it's interesting that they actually thought about that and like tried to make sure.
I'll give you a real life example. This is true. Fingerprints are not completely unique.
Oh, that's interesting.
And there was a lawyer's magazine article about how someone was accused of bombing trains in, I think, Madrid. And he was a lawyer in America. And they finally showed that it was the same prints, but two different people.
Oh, wow. That's crazy.
All 5 fingerprints, whatever they had.
Not just one.
And so
They got 5
fingerprints are not
Seems astronomical.
Okay, so there's a quick, no, this is very simple. If you generate something at random with sufficient entropy, it will be unique for all practical purposes. It's not like a fingerprint. That's it. And that what is generated at random can be in a secret or can be a key pair, or typically for a CDSA, you actually generate the private key and then you multiply that by the
If it's salted with like a timestamp that everybody's using the same clock, then I agree with you. But other than that, then
No. It's typically done. It's done everywhere all the time, and there's no problem. You have enough entropy that's unique. Period. That's the assumption.
it's not just random. It can't just be based on just randomness. Otherwise, you could.
It is based on just randomness. Believe me. The entire world does it that way.
Well, we're going down a rabbit hole.
We're good. Yeah, talk about the top line. Let's off the rails.
Okay, we'll go ahead and go to the next slide, yeah. Oh, and here's just an example that I just want to show of like what these 24 words look like. They're just a bunch of random words that are put together. And this is something that you would have to store privately if you wanted to have a way to recover your keys.
And in a limited database too, though.
Oh, for the key, the 24 words?
Yeah, the 24 words. I forget exactly how many words are in it, but
Oh, wow.
there's a limit to it. So you have to put
Okay.
them in order? No. So
Well,
They are ordered.
you have to put them in order.
yeah, you have to, if you're reestablishing your wallet to recover.
Yeah, to recover, yeah.
Yeah.
Okay, we can go to the next slide. And so I just kind of want to show a picture again. We talked about like the distributed network. We talked about like the public database that each one of these nodes store. We talked about transactions that have a transaction fee, then they have a signature, then they get submitted to like one of these nodes. Then it will go through the system. We'll talk about consensus in a second too, because it's not just one transaction being submitted to the network at one time. You have probably thousands of them going off at once, and somehow the system needs to understand how to organize the database in order. And then you have your queries, which you can go to a single node and read the data that you want and get that out of it, whereas a transaction has to go through that consensus process with the community of nodes in that network. We can go to the next slide. And so, yeah, this is just trying to just illustrating that there's many transactions that get sent to the network all at once. And so I think the next slide is about consensus. So all the nodes need to come to consensus on the order of which the transactions were submitted to the network and written to the database. Different ledgers use different consensus mechanisms to reach consensus on transactions. So in Hedera, we have a consensus algorithm that our CTO invented. We don't have the concept of miners, so we're not a blockchain. And in this consensus algorithm, 2/3 plus one of the nodes have to agree and vote on the transaction in order to add it to the database. And then in Ethereum, you have the concept of proof of work. So you have the concept of miners, they approve new blocks and they add it.
Bitcoin will have proof of work. Consensus now has proof of stake. No, am I wrong?
Consensus, Ethereum or,
Bitcoin has always been proof of work. But Ethereum is proof of stake.
Well, that's a classic, but yeah, Ethereum is proof of stake.
oh, okay. Okay, so maybe we can scratch that. I thought that they were still going through the mining process and adding.
No, it converted back last in September of last year.
Oh, it did,
Proof of
okay.
stake. So yeah, Ethereum
Okay.
right now is proof of stake.
But Ethereum Classic is.
The classic is proof of work, obviously, but
Okay.
yeah, proof of stake. So consensus, you get consensus if you want to invert it. The more ETH you have, the obviously the bigger weight you have. It's instead of proof of work, is using mining machines. They're processing the transactions using CPU power or not CPU. We're talking Super Mario Brothers? No. It's computational power to mine.
Okay, it would take
Proof
a
of
lot
stake
of time to explain.
Yeah, proof of stake is another way of doing things.
So,
I
and
don't understand it. but-
we're actually proof of stake as well. So
Proof of
you
stake.
can stake to our nodes and that stake, STAKE. And you can, so basically the thought is, or the concept is that the nodes that have more stake have more voting power in processing these transactions. We can move to the next slide. Okay, so now that we talked about transactions and all of them are getting sent to the network, and you have this whole database that they're stored in, there's this network explorers. So a lot of the public ledgers out there have network explorers. What network explorers are just a visual way to see all the transactions that are getting processed on the network. And so you can search for stuff, and you can basically search for transactions that are processed. You can search for accounts. You can search for smart contracts. There's all the data that basically the transactions have processed through the network is all the stuff that you can expose basically in these network explorers. And these network explorers offer like the transparency, accountability, and trust because everyone can see like what happened on the network and you can do your own validation and there's nothing that's kind of hiding behind closed doors. So the next slide, I think I just give like a couple examples. So this is Hedera's network explorer. It's called HashScan. You can see the crypto transfers, smart contract calls. We have a service called the consensus service. And so it's like a pub sub queue. You can submit messages to a topic and then read them. But these are basically the transactions. You can see the transaction IDs, the timestamp, and I give one more example. I think it's for Etherscan. And here's Ethereum's, network explorer. You can see all the transactions and their concept of blocks and like all those kinds of things here too. And then sometimes there's these metrics that these network explorers provide about their network. We can go to the next slide. And so then here, I'm just building on this graphic here, just adding a network explorer. So you have your database there, and then there's this nice UI to see, all the transactions that are in that database. Okay, so now that you have all of that, developers can build distributed applications basically on top of this network. And basically, at least in our network, you can call these APIs to read and write from the database. And as I mentioned, the transaction fee are paid in tokens. That's specific to each of the ledgers out there. And users of distributed applications. So if you have the application, then you have a class of users. Usually interact by having a wallet. So if I were to
Database, you mean blockchain, right?
Yeah,
Okay.
yeah. To me, it's a database. It's just rows of data and you can query it.
People understand, I think, but.
Yeah. And then if you're a developer and you're building these applications on any given network, there's usually a test network for you to be able to build and test your applications. And then once you're ready to move it to deploy it, then you'd move to deploying your application to mainnet. And then that's where you'd have to buy like the real HBAR, or the real coin, or the token that you need to pay the transaction fees in. In test networks, you get test tokens to use while you're building and developing. And so wallets, I want to talk about this for a second. So wallets store your private key pair that you use to manage your accounts or your assets. It does not actually store, so let's say if I have an account and I own 100 HBAR, the wallet doesn't actually store the 100 HBAR, it just stores the private key. If you lose your wallet or if you lose access to your private keys, the ledger is still going to have a record that your account has 100 HBAR in there. That doesn't just disappear because your wallet disappears. The only thing that happens when you lose your wallet is you won't be able to access those funds anymore. But it's the tokens are still there.
Safety deposit box, you don't have the key to it.
Yeah, exactly.
Except that they can't break into it for you. Like if you lost your key, you go through a process with the bank of proving that you are indeed the one that was supposed to be holding the key, and
Yeah.
they could eventually just bust it open and take the stuff out. But in this, if you lose the private keys, nobody can bust it.
Right. It's just done. There are different kinds of hardware wallets different kind of wallets out there. There's hardware wallets, there's mobile wallets, there's web options as well. And when you usually sign up to use one of these wallets, the wallet will provide you with like the recovery phrase for you to store and create your keys and things like that.
And paper ones.
Sorry, the bigger ones, yeah, sure.
I said paper ones.
Oh, paper wallets, yeah. To write it down on a piece of paper and store it, yeah,
Yeah.
yeah. And we can go to the next
Are
slide.
most wallet apps cloud-based in the sense they're actually storing it in something that is, or is it just stored locally in that phone?
To be quite honest, I'm not exactly sure how the back end of all of that stuff works. I know if you have like this ledger is an example of a hardware wallet. So like your keys would be stored on that hardware wallet and that's where it lives. And then we have MetaMask and then we have Hashpack, which are desktop and mobile, I think both. And then I think there's also like a Chrome extension too.
Yeah, that basket storing on your desktop on your phone. Technically, you don't want it to be cloud-based because if it's cloud-based, you're afraid it can potentially be
Right,
there.
right.
And what just happened, there was a wallet on Solana.
But the other trade-off is that if it is physical and it's limited to one thing, It's like a very important key, like a physical key that can't, be lost or you lose access to the thing.
Well, if it's on your phone, you get into the issues of SIM swap, and I had friends that had SIM swap where their SIMs on their phone get swapped, and whoever got that phone ended up stealing their crypto.
Well, and also SIMs physically are going away, so that's not a good place to store stuff anyway.
Yeah.
Plus, the hardware of a SIM is flimsy. Like,
Yeah. So USB, is that what you meant by hardware? Yeah, that's hardware.
yeah.
Mhm.
But it could come in other form factors. Like the fact that it has a USB connection is just one way to have it be.
Well, that one has Bluetooth as well, but I don't know if I rely on Bluetooth at all.
Oh, yeah, it does have Bluetooth.
That seems like an anti-feature.
Yeah, exactly.
But it could be the interface that the smart chips and a credit card use. You could build something that was based around that.
Yeah, like,
The important thing is that the private key is stored in that device, and the private key isn't transferred off the device to perform transactions. The signing of things has to happen inside that device. So then the private key doesn't leave that device. That's like the main idea of how that works.
so it's just very well, I don't know if you get that.
But that's the morass that you end up in when you're trying to convert to
Which is the most secure?
a crypto world.
The most secure would be the hardware wallet. Like having it on some sort of physical device or a piece of paper that you store in like a bank or somewhere like that. Internet.
Or your
no
head,
internet.
depending on your head.
Yeah.
So there should be three pictures here. There should be, the very right should be your phone, right? So you have your very left, which should be like your vault, like your safety deposit box, your vault at your house, your safe, right? The middle one is your desktop, where you might do your browsing, buying your NFT or whatever, or transferring it. And then your phone wallet would be what you just need to spend for the day. Right? So if you're going to go shopping, go out to a restaurant, you're going to load your phone up with $100 of crypto, whatever, to spend on your phone at the store so you can check out, right? But you're not going to put any more than what you're going to spend on your phone because you don't want to lose it, right? And
So
so,
if you lose your phone,
Yeah.
that's all you're losing.
yeah, exactly. And so it's kind of like that. You keep all your major wealth in your savings account, right? You keep your other one in your, you have a savings, okay, we'll say this different. You have your retirement account, right? You have your savings account, then you have your checking account. Okay. And that's kind of how I kind of look at it.
Oh, I actually like that analogy. And I didn't even realize, I guess this is in the order of, like, the way that it, yeah, should be. Cool. And then this is just another image of like, usually if you work with some of the wallets that provide you these recovery phrases, this is kind of how you go through that flow. So this is just some other wallet that has a mobile part to it. So this is kind of just supposed to be like a summary slide. I'm not going to go into details with exactly what this has on there, but what you kind of see is just you have your network down at the bottom. You have your nodes there, you have your services and APIs all in there. You have ways to send transactions down, you have ways to read from the database, put it into some front end. That signer with that MetaMask icon right there is what I meant by like most users who will interact with these distributed applications will likely have a wallet that they would need to sign with or do something with. And then you have that in your browser. So this is just kind of a summary of what everything we kind of talked about looks like and what the different interactions are.
And there was permission though, right? And from what I saw, the requirements to be a node operator is pretty darn high.
Yeah, so right now,
30, right?
I think we're maybe about 34
They're all
around
big
there, up
corporations.
to 39. Yeah, so the first phase of it is this permission environment. Then the second phase is community nodes. So community that wants to be part of it the requirements for them to join is going to be different than the council members. And then it will be anonymous, like any one of us will be able to join. So there's a whole
They
roadmap.
are going to decentralize it more like
Yeah,
that.
yeah.
So I guess, if you guys have staking, then how can you have staking end nodes? Like which one,
What do you mean?
like, are you, proof of stake or is it,
So staking is
proof of
this,
work from the nodes?
we're not proof of work.
Okay.
They're staking. So,
Yeah.
I mean, does your stake, when you're staking, the proof of stake is act kind of like a bond where you get slashed if you're a bad actor in the penalty?
I don't know if it does that today.
Okay.
Right now, if you own HBAR, you can stake to the nodes.
You
You
just
can
have a
earn,
certain required amount. I remember there being a required amount. I forget what it is.
you can stake whatever you want. The nodes have a minimum amount, yeah.
Oh, okay, so you're staking and then you're staking on behalf of a node?
So if you're gonna represent via node, there basically there's a certain amount of HBAR that you're required to have. And it's kind of like your initial investment, like, hey, if you really want to participate, you have to have this amount of minimum
Okay.
in order to be represented as a node. Otherwise, we don't think that you're serious enough to represent
Yeah.
the system.
And right now,
By staking almost.
I guess I'm not understanding how you can have, okay, we have 30 large corporations that are official council member nodes, and then, but you could also do staking. I guess I'm not.
so staking is equivalent to the consensus weight for each node. The consensus weight and stake weight is the same. Staking is something that allows retail users or anybody to be able to stake and
What
kind
do
of
you mean
go
the
on.
weight is the same? What does that mean?
So if a node has 1,000 HBAR staked out of 50 billion, then you do the percentage and that's how much consensus weight it has, something like that. I don't remember the math of
The
that.
voting weight.
Voting weight, yeah. So, and the consensus matters with the cash graph algorithm to come to consensus on the transactions that are processed. You need 2/3 plus 1 vote from the system in order to, yeah. So if you have 3 nodes that have 2/3, then that's maybe 2/3 plus 1, then that's all you need for transactions to be processed. If you have 50 nodes that give you that 2/3 plus 1 with that amount of consensus weight, then that's what you need for the requirement. Okay, we can move to the next slide. Okay, application use cases. There's advertising, at least the 2 that I'm just going to talk about here, advertising and supply chain. So a lot of the distributed networks, if you go to their website, they'll typically have a whole page on use cases, case studies, and a whole bunch of stuff. I just picked these 2 because these were the 2 that I'm familiar with, and these are both actually on Hedera, but you can find use cases on any of the Ledger's websites. So one is AdStacks, which is a use case for advertising. So I'm not too familiar with the advertising industry itself, but basically between these advertisers and these publishers, there's a lot of fraud that was happening and not real actual tracking of the events and the return on investment. And it was hard to kind of calibrate how to pay them. And so they're using a distributed ledger to track and verify events. And basically what they're setting to the Hedera network is information about these events, like what you see here. They have like device type, publisher, website information, geographic location. And then that is what they're using as their source of truth of what actually occurred and then how to pay back these people that are involved with this process. So it's a way of like tracking, tracing, it's immutable, it's verifiable. I think those are the sort of the characteristics that they're looking for solutions on a distributed network. And the other one I want to talk about is a supply chain use case called Optimize.io. This is live. It's tracing the product life cycle from the time a product is created to shipping to sale. And similarly, they're using a distributed ledger because they want it to be immutable, verifiable, and have that sort of source of truth on like what actually happened. And a lot of times that I see people wanting to use distributed ledgers is when you're working with multiple parties and doing something, because you have a common shared database that you can't change and you can use for tracking and tracing purposes. But there's plenty of other use cases out there outside of these 2. And here's just a summary of kind of all the stuff that we covered. So maybe I should have started with this first, but I kind of want to go through this story of like building upon it and then saying these are kind of the fundamentals that we covered in this ecosystem.
Another use case is identity,
Identity, yes.
verifiable credentials.
Yes.
Things like that. Are you familiar with that?
Yeah, we have someone at our company named Keith Cowell. He is our director of identity and working on identity use cases.
How does it come from?
Keith, his name is Keith Cowell. He works at our company. Yeah, he's our director of identity. So he's working on director of product manager for identity. So he's working on building out use cases for identity and Hedera and kind of painting that story.
How you know about that yourself? Like if I take you offline at some point, can I ask you questions about that? Or?
Yeah, sure.
Oh, okay.
Yeah, sure.
Another question that I had is, so you said advertising, like, are there any big advertising firms that are using Hedera, and are the council members, like, are they customers of Hedera? Like, where is the actual money coming into the system?
It's transaction fees.
So, and there's enough transactions running to,
I think we have 8 or 9 billion that's processed so far since we've opened. I don't know what that, the math is on that to how much that's, what value that, like, how much that has actually brought in terms of, like, I guess you want to call it revenue or something. But Hedera
I
is,
would like to call it revenue.
Hedera's a nonprofit and it just really has a council that's running and that's it. So I don't really know.
But Swirlds is the for-profit
Yes.
side of it, okay.
Yes, but we have nothing to do with collecting those fees or transaction fees or anything. That's all Hedera. Swirlds Labs is its own entity.
Gotcha, okay. And then, so you and Ken Anderson work for Swirlds?
No, Ken Anderson no longer is with
Okay.
us. Yeah, he is working at Launchpad at his own, I don't know if you guys know Launchpad. but
Yeah,
It's that
okay.
company
Oh,
here in Sacramento.
Yeah.
Yeah.
Interesting.
So he's actually the one that hired me into Hedera like 5 years ago.
Okay. I know somebody that worked at Launchpad, for a little while after working for, I worked with him at the shipping company,
Uh-huh.
and then he went on to work at Launchpad. So it's just funny to say.
So we actually still contract with some of their developers there. I work on a few projects with their developers.
Oh, he's not at Launchpad
Oh, okay,
anymore.
not anymore. Okay, okay.
His passion is doing stuff in biosci, and he found a position where he could code. You know, he's the engineer on the team, the rest of them are scientists, and he's coding stuff that's helping them like sequence things, you know, genetic stuff. It's biosci related.
Okay.
But anyways, he was at Launchpad for a little while.
Oh, interesting.
I do remember him mentioning that a lot of the projects that they worked on for their, because Launchpad does client-based work.
Yes, yes.
But a lot of their clients.
And they do a lot of Web3
are asking
applications
for
development stuff.
crypto-based
Yep.
applications.
Yep.
So it's, I guess, shouldn't be surprised. that-
Yeah.
But do you guys have a relationship with Launchpad, or is it just
Yeah.
coincidence that he?
No, well, he had joined the company. I mean, I was like one of 30, he's probably one of 15, like very early on into Hedera. And so he had already had his software company at that time. And so when we were building out projects, over time, we got contracted with Launchpad because he was working for Hedera and had that.
Okay, so Launchpad actually did some of the work for the code that.
Yeah,
is
and they still
part
do
of-
it. And they still do now. So our client SDKs, they actually are building out the Rust and C++ or Rust and Swift SDKs. They are actually the ones that pioneer Java, JavaScript, and Go SDKs. So, yeah.
But your company is not in the business of collecting transaction fees. You're in the business of developing this as a product, and then the people that are running this network are the ones that pay for that product.
All of the SDKs are open source. So all of these projects that we're managing are Hedera's projects. Swirlds Labs is defining its own roadmap to build ecosystem products to further push the Hedera ecosystem. So
is it kind of like the equivalent of a company that exists to make modifications to the Linux kernel, but they get their revenue from other companies who want to see those changes, they want to see that roadmap happen?
we do have a contract with Hedera, and we're contracted to maintain their open source projects. And then Swirlds Labs, so I guess there's Hedera that is all the transaction fees and network, the infrastructure, a whole bunch of open source projects that Swirlds Lab now that we have shifted, because we only shifted a year ago, that Hedera has a contract with Swirlds Labs, if you look at Swirlds Labs as an engineering firm or a product company, with us to maintain those projects for the next at least 4 years.
Okay.
And then Swirlds Labs separately is creating its own roadmap and vision, it's its own entity, it's its own company. So Swirlds Labs might come up with other products in this like decentralized recovery service or something, other things to further fuel the Web3, ecosystem.
As a way to partition out like the development costs.
Hedera is paying us to maintain their
Right.
code base, yeah.
So then the Hedera world is a cost.
I see, yeah.
But
yeah.
then they're like, okay, well, this is our main revenue now, but we are free to develop other stuff. If it's tangential, we could charge other people for, it's a development.
Yeah,
But you're primarily charging for code cut.
Yeah.
Basically. Okay. But it's interesting because it's all going back into the open source ecosystem.
Yeah.
Is that because crypto people in general say like, if you can't read the code, then it's just.
that actually is the sentiment. So our consensus algorithm and platform code base is actually private and proprietary, and we got a lot of stock for that. So yeah, so we recently open sourced it in this last, I think, year and a half now. And so we had a lot of other, like our SDKs were open source, our Mirror Node Explorer, Mirror Node, other projects were open source, but our consensus algorithm and our platform code was private.
Like you would have more chance of getting away with it the other way around. Meaning that the core stuff, it's like it has to be cryptographically verified. Like people have to be able to look at it, pick it apart and be like, yeah, no, there's no bugs in this. But the rest of it sort of, okay.
I'm a little confused between Hedera and Swirlds Labs. And you said that the consensus algorithm belongs to, it was proprietary of Swirlds Labs?
No.
I thought it was Fastcraft.
So there is Hedera, then there's a company, this is gonna be more confusing, called Swirlds. The consensus algorithm was owned and proprietarily owned by Swirlds, which our CTO was a part of. He was also the founders of the Hedera public network with Mance, and Hedera was sort of licensing, I don't know if they actually paid fees or if it was free or something from Swirlds. Then what happened was, because of all this feedback in the Web3 world, everything needs to be open source and all this other kind of stuff. The consensus algorithm, platform code, all became public and open source. So now the services code base and the platform code base, and they're all in one repo. It's open source. Anybody can view it.
And you are with Swirlds Labs?
I am with Swirlds Labs, which is another.
Yes, a third thing.
Yes,
Okay.
yes, yes.
All right.
I know, it's
I was
confusing.
like, it's okay.
Yeah. Are these all the questions?
Just some of the questions, yeah. There's a couple from June. And then there's probably some more.
Okay.
So June actually does she has like a food marketplace, so she said out in Washington. I don't know if that really would apply to her.
Yeah, I think that, at the end of the day, not all applications are going to be on Web3. It really depends on your requirements and what you're looking for and your use case. You kind of have to go through that process to understand, to see if the Web3 technology is a solution for you. It may not be, because
Right.
Web2 might do everything for you, and then you're fine. You don't need to do anything.
Well, it might be able to use as a payment process, no? Because you have USDC on Hedera, right?
We do have USDC on
So
Hedera.
you could technically take USDC as payment on Hedera using Hedera transaction fees. that happen.
Yeah, I guess as a vendor, you can take forms of cryptocurrency as payment, like PayPal, and I think others are doing.
Answer your question, is government's tracking? Or do you know?
I'm
Yeah,
sure.
it will.
Yeah.
Will we even know?
All of this will be tracked.
Okay. That's more comment, the government tracks everything. Here's something from Karen.
Yeah, I mean, I think that do you already own assets like NFTs or coins or cryptocurrency? I think if you are planning or already own things like that, then you would want to have a wallet. However, you're not interacting in this ecosystem in any way. I don't know that a wallet would benefit you. So I think it depends on like how you're planning to interact with this ecosystem. If you are planning to invest in coins or buy NFTs or are using an application that requires you to interact with your private key to do something, then it would make sense for you to get a wallet. Otherwise, you could still get a wallet today, but you may not use it for anything.
I always ask the question is, what amount of money are you willing to lose? And at that point, if you get above that point, you should be having a wallet.
Yeah, okay, that's great.
Because if you don't mind losing $100, then fine. But if you mind, let's say you have $2,000 and you don't want to lose it, then you should have a wallet.
Yeah,
Because at some point, that money that you have may be $2,000 and,
and you wake up one morning, you're like, oh, wow.
Oh, wow,
What
yeah.
happened? No.
That's how I think.
But is the wallet like cheap or free or something? You can get open source wallet.
You can, yeah.
Yeah, you
It
can get something like MetaMask that's free and you can download it, but that is on your desktop. So any risks or
That's like the word.
Yeah.
That's like the thing.
yeah, the problem is your computer can be potentially exploited, whether you click a bad link through an email, whether you go to a bad site.
But the price of the wallets is
Right there.
totally independent of the price of your investment.
Well, wallets are typically.
Those are some, hardware wallet. You can buy a treasure anywhere from about $69 to $200. You can buy a ledger about $149. So that's why I always ask is what well, at what dollar value are you willing to lose? Because there is an investment to buying a hardware wallet, right? But that is an additional level of security. Yeah.
But I don't think hardware wallets can make a race to the bottom as far as, because the only way you can do that is to have the components, the supply chain of the components would have to be a questionable,
Are you guys on point?
like they're
We
compromised.
are now.
Before they're even assembled.
We are now, yeah.
Yes, yeah, they're compromised. I mean, that's another question is, do you have an exchange if you're keeping your stuff on an
Yeah, that's-
exchange?
yep.
You know, the issues with being on an exchange is they're not FDIC insured. So if there ever was an event with the exchange having an issue, you could potentially lose your funds.
That, and a couple of them are leaving the US this year.
Yeah.
So Bittrex, and I think, heard, I don't know if this is a rumor or not, but maybe Binance US. And if they're leaving, then you kind of got to figure out where to move your stuff to. And therefore you would need a wallet.
What are examples of big companies using this for something that's providing value to them? Like they're putting money into something. and
Those two that I shared with you, and there's more on our, I think Denton's, DLA Piper, these are all enterprise companies. They have actual use cases that are running on their system.
Piper's alone.
Yeah, it is. And you can read their case study on our website.
So their court cases probably up there.
What's that?
Are there court cases on the blockchain? Like, what are they putting on the blockchain?
They're tokenizing assets on there or something like that.
Tokening assets.
Like they're called, I think their product is called Toko.
Huh.
And yeah, I don't remember the details of it, but
What kind of assets they're putting in would be interesting.
yeah.
So this is, so last year, actually the last few years, crypto and blockchain have been really big, and in fact, NFT was the rage like last summer. I mean,
Yeah.
a ton of people. But now it's like AI is the rage now. But all that said is now that the hype has sort of been moved out, is this like, is now where the real work is starting, or the real benefits are, that now that the hype has sort of gone to somewhere else? Do you feel like you're busier or less busier?
More busier, and I think we as in like Hedera or Swirlds Labs have always, our focus has always been to build meaningful use case applications on top of Hedera. It was never really about NFT hype. It was never really about any of the hype stuff that you see. And our developer advocates and BD team and the HR Foundation and now grant funding organization that split from Hedera as well. When we split into Swirlds Labs, so product and engineering went to Swirlds Labs. The BD team went to the HR Foundation, and we're in it for building those lifelong 100-year applications, not this
hype
stuff. Yeah.
So it's actually good that the hype sort of gone out and.
Yeah, and I think that even with this being sort of a crypto winter, like the amount of meetings and engagements that, Hedera is still getting for people that want to build hasn't stopped.
Okay.
Yeah.
Good to know.
Yeah.
Yeah, I mean, personally, I've been very skeptical of cryptocurrencies. So I'm an interesting case in this room, perhaps. Well, because it sounds like you're definitely into cryptocurrency. Okay.
I'm out.
And
I'm
But-
ready.
the one thing that has caught my eye is the idea that you can deploy distributed applications. So it's a different way of deploying stuff. Instead of saying, okay, well, you need a bunch of centralized hardware to scale up an application. That's why you just keep reinventing things like Facebook, like Twitter, right? The more people used it, the more hardware they needed. But a distributed application runs off the network. And the network exists because all the nodes get paid in order to run.
Now you're getting the dream.
But I didn't see anything that was actually providing a
You need to
distributed
know.
application that
You
was
need to make
deployed to
We're waiting for
companies.
you, Tim.
Okay, so I have a question in regards to that. Like, how scalable is Hedera in regards to transactions? Like transactions, how many, the throughput is how many transactions per?
I think it's insane, right?
It's
really
It's 1,000 TPS right now. I think the max, actually, I don't know what the max we've seen live, but
So how does that compare to like
1,000
Visa?
TPS. It's about the same.
About the
I
same
think,
as
yeah.
Visa are now?
Yeah,
Okay.
and that's the cap that we have right now.
And
It's
how-
not beyond that.
Hasn't been tested?
Yeah.
And
As far as I understand, I haven't
these
been.
are all still the same? These are all still the same?
Yep.
Okay.
Fees are so.
Absolutely.
I think we only changed the fee once so far for an account. It was 1 cent. We moved it to 5, but that's the only like fee change that I've witnessed since I've been here.
Do fees go up if there's more demand on the
No.
network? Okay.
Well,
Your transactions might get throttled because there's more demand on the network, but
So how are you guys going to address, spamming of the network with transaction spamming? So for example, like one of the things that you'll see on Ethereum is all these wonderful airdrops. And the fact that they'll just randomly spam your wallet with, on Polygon, with random NFTs and other things.
so there's 2 features on our accounts. Accounts actually by nature, you can't spam them because the user has to provide a explicit association to the account first by signing a transaction, and then that then that token can come into your account. However, since then, we have added another feature to accounts, which says, I have an account, I will allow 100 open slots for tokens to be sent to my account. And then at that point, you might get spammed, for those 100 slots. But it's up to you and how you build your account. So you can set it up so you don't get spammed, or you can set it up so maybe you're taking some risk on spamming because you're allowing 10 auto associations.
You just have a spam wallet that accepts spam, and then you can have another one that doesn't accept
Yeah,
spam.
exactly. Yeah.
That's actually kind of cool.
And so I think the reason why your guys' fees are able to go so low and you have such high throughput is because you just have 30 nodes that are just reputable big companies.
I don't know if that has to do with that actually, in terms of,
That's the Walmart approach. That
Yeah.
It's all about how the volume of transactions, and they'll make money on the volume of transactions, and they probably realize that, which is a smarter way.
Well,
Trying to make a few transactions and make a big pop off of a few big transactions.
I feel like
It's not a free-for-all. You can't
Well,
join that network.
yeah, so I feel like if there was, 3 million nodes, it wouldn't be able to go through, quite as fast as there's just
Well, there's
30.
latency and other things you have to consider in those situations, but then there's sharding, which is a whole other concept that you can do to alleviate some of those things. So maybe you have sharding for specific use cases and things like that, but yeah.
That's what I changed.
It's okay, I didn't know, just almost 5 years ago either. It's just, a sharding just partitions of a network or database.
I mean, I think that from the standpoint of like traditional legal and real estate, this could potentially change those things, because if you're doing
Well, it will as long as the regulation allows it to, which is another story for another day.
well, it needs to be reliable. That's the only-
It's way more reliable than.
But so like right now, if you want to, if a property is going to change hands, you can't just give one party the money and then the other party takes the property. Like there's a whole bunch of paperwork that has to be filed in order to show that they really meant to do it.
Escrow.
In
Right.
Both things and then distributes them.
But this type of technology,
Escrow is automated in this. That's what a smart
So,
contract.
in the fraud that's occurring is, real estate brokers or other people are being hacked and they're being provided, somebody else's bank account or
Right.
in order to wire to send funds to close the transaction. So there'll be ways, aren't there, for, the hackers to get in? So how,
Only if there's exploit in the code.
Yeah.
how is the lab?
Well, I think that from the point
How
of
is
standpoint
that
he's asking the question, it's not
But
just
is
whether
the which
it's core
labs?
protocols.
Oh, my company, for exploits?
How are they preparing for the hacking and for the spamming? And, I mean, it's not just in the US, there are people all over the world that are going to try to break in wherever there is some money, right?
Yeah, so I know that there's a lot of effort being put on getting audits and things like that done, and then also having like malicious playbooks and things that like we can operate and follow in case we're in some sort of event like that.
It's only as good as the programming, as the code.
There's always doors. No, there's not always doors now, somewhere, no. But you keep getting updates on our.
It's called keeping it simple. Yeah, if you allow updates. The thing is, when you launch a mutable contract, immutable is unchangeable. And so in theory, the way these things should be built is you should have a protocol, right? Just like we have SMTP for your email. You probably don't know, I don't know if you know what SMTP is, right?
Yes.
Simple mail, whatever it's called. But you have Google and you have all these other guys using the same protocol. Okay? That protocol has been tested. We know that the protocol works. So in theory, what you do in the blockchain is you can launch a protocol. That protocol might be the protocol that allows you to do lending or an escrow. right?
Didn't get all of
You create businesses on top of
They're
that
actually
protocol.
answering themselves.
Protocol hopefully has been tested, bulletproof, and has no problems. Okay? Nobody can change the protocol. Okay? The businesses on top of the protocol are the ones who are responsible to use the protocol properly. Now, these businesses who are using that protocol, if there's an issue, the issue would be with them and have to be addressed with them. But the protocol should be resilient, and it should not be able to be changed. With that, yeah, there's direction. But if you have a protocol that only has certain functions like deposit, withdraw, you can't exploit that. It's a smart contract, it's code that it will only let you do two options, deposit or
The
withdraw.
protocol is very secure by design. And you're focusing on that, but really, from a user standpoint, the real issue is the wallet becomes this fundamental linkage
Yes.
in the whole thing. And if somebody's wallet's compromised, then all of the things that could be done with their private key.
It takes responsibility, unfortunately. And people have to learn to be responsible
That's,
for their own wallet.
that's to me like the thing that, because I'm a technologist and the more I understand about how it works, the more one of the reasons I didn't go and start mining for Bitcoin when it first came out was so I was just like, at the end of the day, this stuff is only as secure as where my private keys are. How do I continue to have that on the network and have that private key be secure? It seemed like it was a difficult game to play, since most operating systems are not very secure. So the algorithm is secure. The idea of like how transactions are signed and whether or not you have a real proof there, that's much more mathematically provable. But then you have that stuff running on individual devices that it's like, those things are like Swiss cheese.
Because they're going to be updated. So I came from an IT, construction estimating, and real estate background. And so in 2020, I actually found this metaverse called Decentraland,
Yep.
right? And at the time, I was actually looking at buying a foreclosure. And I was finding out information on this property, and the guy told me, and when I called the title company, it'll take us 2 weeks to find out information. I went, well, 2 weeks to find out information on this property and the title of the property. I'm like, that's a joke. In the meantime, I'm looking at a virtual piece of property, a video game property. And I could see every transaction history on the blockchain for when this property changed hands, who owned it, what price they bought it for, and all that on the blockchain. I'm like, this is really cool. I could see where this technology could take place. But it's anonymous? No. Pseudo-anonymous, maybe. Pseudo-anonymous. You guys are saying that things are anonymous. The data, something's anonymous.
So
They
you,
can't come back to us?
So-
Trace it back to us?
it depends.
Yeah, it depends.
Oh, it's traceable.
Well, if you have your private key, if you use an exchange, then you can tie the transaction from an exchange to a network. The moment you link to something that KYCs you, then you can be traced. If I use an SDK, I create a pair of keys, I create an account on the network, and I start doing stuff with it, there's nothing to tie my name or any piece of information about me to that transaction.
Not true.
How would,
So you can have these little things called NFTs that people use as personal profile pictures. The moment you tie that to an address and you can
So
call
I-
that chain,
yeah, so I guess without doing that, I'm just
Yeah,
going to
without
get a private key and create an account, no NFTs, nothing like that to associate.
just the wallet, just by
Just-
itself,
yes.
you're set. You
Yeah.
should be pseudo-anonymous. We call it pseudo-anonymous because unless somebody can identify your address, you're anonymous.
And the moment you give someone your account ID or some information about what accounts you manage or NFTs you own, then also you can link.
You're no longer anonymous when you
Yeah.
find everything you
I
do.
think in practice, it's not. In fact, I think that the key, I think that government is not going to let this stuff continue to exist unless anonymity is taken out of the case.
I think they want people, I think they want the public surveillance system, my own belief, whatever.
But we can flip this
Because
on its head.
if you look at,
Because think about the way money works now at the governmental level, right? Tax dollars go in, where do they go?
well, I think there's.
But if everything is on the chain, then every dollar that's ever
Oh, I would
collected,
love that. That'd
Would-
be good for them.
we would be able to trace where it went.
I know.
And that's actually their fear, I think, at the end of the
I
day.
think so.
It's more than the fact that
But
the
it-
system
it-
as we know it
but
would have to change.
It's not traceable between exchanges because the exchanges end up acting like a black box. Because they have their own personal private ledgers. And so that would just still continue. It'd only be the public who would be probably.
Right, the more entry points and exit points you have between various stuff, the harder it is to trace.
You guys keep telling me that there doesn't seem to be a way that you see to hack this. Maybe we're not seeing it.
It could be exploited. Most of it's
So
exploited.
the most fearful development in this is that quantum computers develop so quickly that the size of the keys we're currently using become shrinkingly small.
Right, that you can solve it.
The size of a key 30 years ago that was secure is not secure now. So, but we've gotten to a bit size that's like, well, at the rate the computers are getting faster,
There's
those
concern
keys are still secure if they're Turing machines that are processing it. But if they're quantum computers, then all bets may be off.
So I understood that ED25519 keys were quantum proof. If you're using ECDSA key types, then they're not, which is what other networks use. But from what I
There is research on whether or not quantum computers can perform certain kinds of cryptographic functions any faster.
ED25519.
That was on that, one of those slides.
Yeah.
Basically, what
So
you're saying is
the-
quantum
So
cryptography.
the reason why, so Hedera actually only supported ED25519 because their CTO was like, these are quantum proof and we need this for the future. The only reason why we added ECDSA key types because that's what the market uses. And to be compatible with
ED
25519.
5519.
Easy for you to say.
That's it. The end one. Five, what's the advantage of the get home card? What is it?
Sorry?
What's the advantage of
The
the
E-
get home card?
As far as I understand, the ED25519 keys are quantum proof.
Well, they have 155.
Yeah. As far as I understand.
Meaning that the algorithms that make them work, even when executed in a quantum computer, they don't run any faster. So you don't have any way of searching for keys any faster using a quantum computer than you do a regular Turing machine.
How is that possible? The whole,
Dude, you think we're talking theoretical earlier? Like that's, like now you're talking about just
I don't-
mathematicians.
I don't know what I'm talking about.
Your walls probably aren't big enough to worry about it. Is there insurance out there? What if there is a fraud or something? Is there insurance?
There are insurance protocols.
Insurance policies.
So Hedera, let's say something happens on the Hedera network to a user or somebody, there isn't anything that we say or have a policy in place to say, oh, if you get hacked and your assets get stolen, we're going to give it back to you or anything like that.
So
It might be with some wallets. Some wallets might give you that guarantee. Like if your wallet has been hacked and people were to take funds out, they might say they might reimburse you for it, but
most hacks are actually associated with social engineering. And so,
Say a title transaction occurs, the title company signs it, the whole thing is just completely done, and then it turns out there was fraud.
The money didn't show up.
How do they
Why are
unroll,
saying, where'd my money go?
how do they unroll that? But at the end of the day, does that title transfer no longer exist? Or is there a new title transfer that corrects
They
it?
normally don't undo it.
Right, you can't undo it. It's an immutable,
Because the
once it
buyer
exists.
sent the money to the
Record it.
wrong place, whoever gave him the wrong information committed the fraud. The seller gets to sell. So guys, if I'm following you right so far, we are envisioning, because of the speed, that we will be going to hire one of these webs, whether it's a 2 and a 3 or what you were
5.
talking about. I don't even know what that means. What is this augmented and the virtual reality stuff? Because I went to North American, South Asian Bar Association conference last summer in San Francisco, and Coinbase's lawyer, Paul Grayball, was looking right at me, and he answered the question. He said, "This is all metaverse." This is, what's that again? And he was using these, again, these words in these Web 2.0 report. So it's just coming
yeah, it's an interaction of how we're going to deal with the web and the
because it's efficient and because it's faster
I think
it's more secure
and secure.
and secure.
securing, that's a different way of looking at how data sits in that ecosystem.
It's definitely coming, but it's being held, in my not humble opinion, it's being held back by regulatory.
So here's part of the thing right now. Part of the reason why we have like hacks and exploits is, and granted, a lot of these can be clawed back. So for example, a credit card transaction or debit transaction is a pull transaction, right? They just pull money out of your account and whatnot.
Debits, they are right away.
Yeah, exactly. And so what happens is that creates additional risk, right? So banks have to spend a lot of work unwinding all that stuff and all that, right?
Your
In crypto, and everything is a push transaction. You cannot pull anything from me. You can't steal from me. You can't hack me unless I've approved it.
Okay.
If I sign a bad contract, if I click on a bad link, if I approve it, then you can steal from me. But I had to actually approve something for you in order for you. Okay, that's
Please, that I've met about things happening like this is, and I sent you a LinkedIn, Cindy.
Oh, great, thank you.
Where I've seen anything like this happen is where seniors have cell phones, and if they have a wallet or wherever it is, and somebody, you do certain kind of a text to press to do something for your phone banking or whatever, and then they get to your device and they take your keys, right? You're talking about private.
Yeah, I think it's a good do that on there.
Yeah, so it's more of the social,
Oh, here.
So that's,
I just sent me an invitation.
Yes.
that's like getting people's keys, yeah, people are not aware that they need to protect it, yeah.
Just like, Brian.
So what is it that you do?
But I have people,
Yeah,
my
I want to
grandfather.
talk to you about credit cards. So I don't know. I do need to talk to you.
If you're not smart enough to say no.
hold on a second, guys, I'm gonna, you guys,
No matter what.
I'm gonna wrap up here and then shut off the WebEx meeting. So, Simi, thank you so much for presenting.
Thank you.
And, yeah, thank you very much. It actually, I like the way you explain a few things too. So I really, I think it helped a lot of people, or maybe confused more, I don't know. And I just want to talk about what's coming up next week. We actually have a monthly startup pitch workshop. So if you have, if you're looking for money or you have a pitch, you could apply to be part of the workshop. We could look at 5 startups. So I have a panel of 3 pitch coaches. You get to pitch for 5 minutes, and they will give you feedback. And then if you do impress the coach, we can actually recommend you to pitch in front of actual curated group of curated investors in Folsom. The week after, we're having a workshop on servant leadership, and then the first Wednesday of the month we have Founders Anonymous. So what that is it's basically if you have a problem, the community come. If you're a founder or an entrepreneur and have a problem, you can come to this group, and as a community we can help you work out your issues. And then the second Thursday of the month is Beer and Geeks, one of my favorites because I just show up and have beers with my friends. And then, so that's the next few events coming up. So what we're trying to do is we essentially have a pace of an event a week. So you can see the schedule on Startup Grind /Sacramento or startupfolsom.org or Eventbrite, and you can search for that. So with that, thank you very much for coming today. I'm going to go ahead and shut off the virtual, and then you guys could continue your conversation.
Yeah, thank you.
All right, thank you, Rich. Thank you, Rich.
Yeah.